State 1 conservation law that would be violated if the following reactions were to occur. So the first reaction, pi 0 becomes positron and muon. So let's consider charge. We can see that 0 is plus 1 minus 1 is 0, so charge is conserved. There are no baryons, so we will not check baryon number. And let's consider lepton E number. Pion is not lepton at all, so its lepton number is 0, and also lepton E number is 0. And positron is antiparticle, so it's negative 1. Muon, it's not electron lepton, so its Le value is 0. Or actually, if there is only one particle which belongs to electron lepton group, it means that it cannot be balanced, hence it's definitely Le value is definitely not conserved. Or to show like this, hence electron lepton number is not conserved. Also we can see that muon lepton number is also not conserved, because 0 is 0 and its particle, a negatively charged muon is particle, so it's plus 1, so we can see that it's also not conserved. The second equation, let's check charge, plus 1 minus 1, so we can see the charge. For charge, plus 1 is not equal to 0, so charge is not conserved. Also let's check baryon number. Proton, positively charged, it's particle because proton is usually positively charged, so baryon number plus 1, it's particle, it's anti-neutron, it's antiparticle, and there are no baryons on the right hand side, so its baryon number is 0, so we can see 0 is 0, so it's conserved. And what about lepton E number? Particle 0 on the left hand side, particle antiparticle, particle antiparticle, so 0 is equal to 0, so it's conserved. There are no other types of leptons, so we don't need check lepton mu number or lepton tau number. But you can notice that if you consider just lepton number, it is conserved for the first equation, but its lepton number is not conserved if you consider each type of lepton. And the next question, the reaction given is an example of a neutral current reaction. Draw a Feynman diagram for this reaction, labeling all the particles involved. So time is to the right, so initially there are two particles, muon, antineutrino and electron. Electron is a particle, so arrow must be to the right. Muon, antineutrino, antiparticle, so to the left. And after we have the same muon, antineutrino and electron, and there is an exchange particle, and question is, what is an exchange particle? Is it gamma, and is it electromagnetic interaction or not? We know that electromagnetic acts only on charged particles. Neutrino is not charged particle, so it cannot experience electromagnetic force. So it's not gamma. Exchange particle is not gamma, hence it's the weak interaction. And we know that charge must be conserved at any node. And if we consider, for example, this node, we can see that charge in is 0 and charge out is 0 plus charge of the unknown particle. So our exchange particle has 0 charge, and possible exchange particles for the weak interaction are W plus W minus and Z0, and since it has 0 charge, so it's Z0. And we can check for another node. We can see that charge in is -1 and charge out is 0 plus -1, so it's correct. So it looks like this. And that's all for this question.